Good day, everyone. You're welcome to today's class. Today, we want to solve problem on calculations that involve reactance of the circuit. And let's see what's on the board. The frequency of the AC supply shown in the figure below is 200 over pi hertz. 200 over pi hertz. What is the reactance of the circuit? We are told to look for the reactance of the circuit. And we have different types of reactance. We have a capacitive reactance, we have inductive reactance. Is that okay? And let's know the one we have to look for. So far, you have capacitor in the circuit. This is symbol for capacitor, having the same line equal. Okay, that shows that we are looking for the capacitive reactance. Okay, because the question says what is the reactance of the circuit? Since the circuits of capacitor, is that okay? That means that we are going to look for the capacitive reactance. That is capacitive reactance, which is 1 over 2 pi Fc, because circuit is of capacitor. Now, we are given the frequency. You can see frequency of the supply. This is supply shown in the figure below. F equals 200 over pi hertz. That's our frequency. Well, let's see the capacitor. Let's effective capacitor. The effective capacitance of the capacitor. The effective capacitance of the capacitor is 5 microfarad plus 5 microfarad, because they are in parallel. Let me write it like that. Effective capacitance of the capacitor is in parallel. In parallel connection. Due to that, you now have C effective capacitor equals C. Okay, let's see. Since we are not, so the C1 or C2, let's just say 5 microfarad plus another 5 microfarad, which is 10 microfarad. C effective now equals 10 microfarad. Because they're in parallel, you add them together. If they are in series, you find the reciprocal of each of them. It's 10 times 10 raised to the power minus 6 farad, because micro is 10 raised to the power minus 6. Okay, the effective capacitance of the capacitor is in parallel connection. Now C, therefore C effective equals 5 microfarad plus 5 microfarad equals 10 microfarad. Now, you now go back to your formula. Capacitive reactance equals 1 over 2 pi times, what's our frequency? 200 over pi. Capacitor times, you can see it, times 10 times 10 to the power minus 6. Pi cancel pi. Capacitive reactance equals 1 over 2 times 200, that's 400. 400 times 10, that's 4,000. 4,000 times 10 to the power minus 6. Now, capacitive reactance equals 1 over, let's take this one into standard form. Shift 3 times 1, 2, 3. So that I can combine the power. That's 4 times 10 to the power 3. We are shifting from right to the left. it will be positive index or positive power times 10 raised power minus 6. When you pick 110 to stand for the 210, the power will be positive, multiplication change to positive. That's law of indices, one of the laws in the indices. Now 1 over 4 times 10 raised power 3 plus minus 6. Now capacitive reactance equals 1 over 4 times 10 raised power positive and negative as negative. That's 3 minus 6. Okay, which equals to 1 over 4 times 10 raised power minus 3. Now let's separate them. XC, capacitive reactance equals to 1 over 4 times 1 over 10 raised power minus 3. Don't forget in indices that 10 raised power minus 3 equals 1 over 10 raised power 3. Okay, that's what it stands for. Now when you now introduce it here, it will go up equals to 1 over 4 times 1 over, instead of writing 10 raised power minus 3, write 1 over 10 raised power 3, 1 over 10 raised power 3, which is 1 over 4 times 1 over 1 over 1000. Okay, okay, let's just write it as, uh, let's take it as this. This one they are together is 1 over 1 divided by 1 over 10 raised power 3. Now, xc equals 1 divided by 4. 4 goes in 1, impossible 0 point. Add the 0. 4 in 10, 2. 4 times 2, 8. 10 minus 8, that's 2. Add 0. 4 in 20, that's 5. 4 times 5, 20. Now, we x to be 0.25 times 1 over 1. Division will change to times. The 10 raised power 3 will go to the numerator, 10 raised power 3 over 1, which is equals to 0.25 times 10 raised power 3. Okay, now what we do now is that we want to shift to the right. When you're shifting from the left to the right, the power will be negative. We are shifting 2 times 1, 2. Now with xc to be equal to 25 equals to 25 times 10 raised power minus 2 times 10 raised power 3, which is equals to 25 times 10 raised power minus 2 plus 3 equals 25 times 10 raised power minus 2 plus 3 as 10 raised power 1. Okay, therefore, therefore, our capacitive reactance equals 25 times 10 raised power 1 is 10, which is 250 ohms. Okay, capacitive reactance, which is the question, what's the reactance of the circuit, which is capacitive reactance, equals 250 ohms. That brings us to the end of the class. Please don't forget to subscribe to the channel for more updates. And also, don't forget to leave your question in the comment section. Thanks for watching. See you in the next class. Have a wonderful day.